In this video, you'll see how to solve and write proportions. So a proportion is simply two equal ratios. So for instance, a proportion, I could write a ratio like 3/8 and something that would be equal to that. If I multiplied the numerator and denominator by 3, I could get 9/24. And these are proportional, we would say. So we can test to see if two ratios form a proportion. And the way we do that is if the cross products are equal, then the ratios are proportional. So if I'm testing, if I want to see if 9/32 is proportional to 4/15, I'm just going to multiply 32 times 4. That's 128. Then I'm going to multiply 9 times 15. That's 135. So these are not proportional. I could also multiply 14 times 15, and that is 210. And then 42 times 5, which is also 210. So 5/14 is proportional to 15/42. We saw the way we solve proportions. So if I have a proportion like this one, x over 8 equals 5 over 11, I'm going to cross multiply and then I'm going to solve the resulting equation. So by that I mean I'm just going to multiply 11 times x, which is 11x. 8 times 5 is 40. And then I just need to solve this one-step equation here. Divide both sides by the coefficient. And x is equal to 3 and 7/11ths, or you could just leave it as 40/11ths. Either way is fine. Now, I also can use proportions to help me solve word problems. And so when I'm using proportion to solve problems, I want to be sure that I'm consistent with my units, and I'll show you what that means. Okay, so for example, if one side of my proportion compares words to minutes, my second side must also compare words to minutes. So let's take a look at an example here. A microchip manufacturer inspector found 3 defective chips in a batch of 750 chips. At that rate, how many defective chips will there be in a batch of 10,000? Sometimes this is a key phrase here, at that rate, often telling you that you're going to use a proportion to solve. But when I know I'm using a proportion, I know I'm comparing different units. So for instance, I'm comparing defective chips to total chips. So defective chips over total chips. And so the first part of my question is asking, okay, well, there are 3 defective chips out of 750 total chips. And then the next one is how many defective chips over 10,000 total chips. So this is what I mean by being consistent with my units. On the left side, I'm comparing defective to total. So on the right side, I also have to compare defective to total. And I am going to cross multiply. 3 times 10,000 is 30,000. That's equal to 750 D. I'm going to divide both sides by the coefficient here. And I could divide 3,000 by 7, or 30,000 by 750, but I'm also just going to try to reduce this out. So divide both by 10. 3,000 divided by 75. Well, I could divide 3,000 by 5, and I'll get 600. If I divide 75 by 5, I'm going to get 15. I can divide both of these by 5 again. 600 divided by 5 is 120, and 15 divided by 5 is 3, and then I can see that 120 divided by 3 is 40. So my answer is 40 defective chips in that batch of 10,000. Now you could set up this proportion in different ways, right? So instead of saying 3 defective chips to 750 total chips equals D defective chips to 10,000 total chips, think about some other ways you could set up this proportion and still get the same answer. All right, here are some problems for us to practice. I'm going to cross multiply to solve these proportions here. 2 times y is simply 2y. And then 25 times 15, that is 375. And divide both sides by 2, and y is equal to 187.5. And the next one here, I'm going to multiply 4 times 3.8, and that gives me 15.2. It's equal to 5m. Divide both sides by the coefficient here. 15.2 divided by 5 is going to give me 3.04. And that's what m is equal to. And finally, I have 2/5 over 9 equals 12 over h. I'm going to cross multiply here. 9 times 12 is 108. 2/5 times h is just 2/5 h. To solve for h, I'm going to multiply both sides by the reciprocal of the coefficient. So I'm multiplying both sides by 5/2. And I can cross reduce here. 5 times 54 is 270. So 270 is equal to h. And that's how we solve proportions.